Hello everyone, let's see the solution of this amazing problem. Question says the car starts from rest and speeds up. We are plotting its velocity versus time graph here. On y-axis we are taking velocity, on x-axis we are taking the time. Okay, t is equal to 0, the velocity of the car is 0, then it speeds up at constant rate. So the slope of velocity time graph should be constant because the slope of velocity versus time graph is the acceleration, that should be constant. And here the car achieves the maximum speed, we call it V max. Suppose car achieves this maximum speed at time t1. Okay. After that the car slows down and comes to rest. Question says it slows down at constant rate and finally comes to rest. This time taken is t2. From here the time taken is t2 to come to rest. Getting this? Now we need to find the maximum speed of the car as well as the distance traveled by the car if the total time of the journey is given as t. Okay. Since acceleration is constant, we can easily use the equations of motion for constant acceleration. So when the car is speeding up, I am applying the first equation of the motion, which is v is equal to u plus at. When the car is speeding up, at that moment the final speed we can write as v max. When the car started, its initial velocity is 0. We are writing the data for this interval of the time. Acceleration of the car we treat as alpha and the time taken is t1. So we got here that t1 is equal to v max by alpha. Agree? Now the car slows down. For this interval also will be using the first equation of motion again. So if we use the equation again, what is the final velocity? At the end of this interval t2, the final velocity is 0. So let us write it 0. What is the initial velocity? It is v max for this interval. And how much is the acceleration? The car is slowing down, so the velocity and acceleration, they are directed in the opposite direction. That's why I am considering here a negative sign, and the data here is beta. Time taken is t2. Okay, so from here we can write that v max is equal to beta t2. So the t2 comes out to be v max by beta. Let us save this data also. Done. Now according to the question, the total time of journey is given as t. So the t should be equal to what? Correct, t1 plus t2. Putting up the data, t1 is v max by alpha, t2 is v max by beta. And here we can take that v max common. So we are left with v max 1 by alpha plus 1 by beta. This is expression. Okay. Here we can take the LCM and simplify the things further. So writing that data here, t is equal to v max. Taking the LCM, it is beta plus alpha upon alpha beta. So when you want to write the expression for the v max, you will get a simpler formula. Shift the alpha beta here. Alpha beta t divided by alpha plus beta. Agree with this expression? Now we need the distance traveled by the car. That can easily be solved. The distance traveled is area under the velocity versus time graph. So computing the distance traveled here is equal to area under this velocity time graph, so that is half into base into height. Base is t and the height is v max. V max we have sorted out right now. So the distance traveled by the car, by the object, by the particle, whatever we consider, is half t into alpha beta t upon alpha plus beta. So the final answer is alpha beta t square by 2 alpha plus beta. Got it? So here are the two answers. The maximum speed will be alpha beta t upon alpha plus beta, and the distance traveled will be alpha beta t square upon 2 alpha plus beta. I hope you understood the solution. Stay awesome. See you again.